So just a quick slide about who we are. We are one of the New York fastest startup companies, mobile-first companies. What we do is we deliver instant win experience, promotions and rewards. We have this unique app where we give our consumers a unique way of discovery of the product through our brands and mobile gaming centers. We have close to 20 million installs in the store app. We are the top 3 lifestyle category app in Android and top 10 in Apple Store. We have close to like 15 million weekly consumers that access the app, and we are able to deliver a customized brand experience for these folks. And in return, they get to play and win prizes and real money. So we had a $1 million contest Q4 last year where one user won that $1 million. So a pretty happy user. So I wanted to kind of start with, how did the whole requirement start? So, one day the founders kind of came in and said, hey, it's great that we are doing personalization when the user comes back, but we want to start doing more intra-session personalization. So what I mean by that is if someone plays a game, if someone likes an ad, someone does an install, we want to be able to show an ad that is more tailored to them. We want to be able to show a contest or a product-based contest that is more tailored to them. And this kind of increases the session length for the person. This also helps with the retention for the person to come back. So once we implemented this whole intra-session personalization, our retention and sort of our targeting was much better, and we're seeing much more conversion in our app. So obviously that was the business lingo. From a tech lingo, what that meant was when the user is coming in, we should be able to measure all user interactions within the app. This is every minute bit of interaction, their device settings, whatever we are able to access, we should be able to do that in real time. And then the second one was being able to classify the users using all of that data. And again, that is in real time. So within our session, we have this concept of, we call them cards, opportunities that people play. And between opportunities, there is a lag of like 1 to 5 seconds. So within those 1 to 5 seconds, we should be able to take all the data, decipher what they did previously in that card, and be able to show the next lineup of cards as soon as that card is over. And then the third piece of information, the requirement was pretty critical for us is, we as a game app, we work with multiple partners, whether it's our A/B test framework, whether it's our ad server, or whether it's our targeting framework. We work with all these partners, so in order for them to deliver the right content, we had to make sure that in real time these are delivered to them so they can act on it and deliver the right content or the right ad to the system. So quickly kind of jumping into the technical design. This was the easy part for us. So as you can see on the top, we have different touch points for the users. We have a mobile app, tablet, a lot of web content, a lot of social content, and then a lot of third-party data that we get from our attribution partners and other partners that we collaborate with. So as I was saying earlier, we had to first design a very scalable data layer that can collect that data at scale. So that was easy. We did an elastic beanstalk collector layer, pretty simple REST service that can collect any type of event data. And we use Kinesis to send that data to Kinesis, and then from there, there's multiple readers that act on it, whether that's analytics or some monitoring system, whatever that is, everything acts on top of that. And then the second piece of component that we built was a classifier engine. So this is an engine where anyone in the company, stakeholders like product or ad tech folks, they can go in and they can create rules around these events, and they can start segmenting people. Like anyone who has done an event in the last 7 days, or anyone who's doing it right now, or anyone who has passed the tipping point of a certain barrier, they can be allocated into segments and audiences. And then once those people are segmented, then from there, these data points are sent to our partners for activation and into our system. And then obviously the engine required a lot of metadata in order to get the context of what they're playing, what is the value of the card they're playing, and stuff like that. So what we did was we had our operational store, which is RDS Aurora, and in order to be able to pass the data in real time, the metadata in real time into our store, we use the Lambda triggers on the table. So every update, every mods, Lambda triggers, they send the data to our Redis cache, and then from there it's available to the classifier engine. So every new person that enters the app, the information is available to the classifier engine right then to classify it, rather than wait for the data to come in. And then obviously the segment store, that's a NoSQL store to store the segments. It's a fairly key value based store, so we didn't have to do much thinking about it. We knew from get on that it was going to be a NoSQL store. The missing link was here, the ability to transfer the data in real time to our partners, to our data lake, to our replica store, so that we can act on it. So what were the requirements of the missing piece? So as I was saying, we have multiple partners, our ad servers, A/B test frameworks, all these partners. So the goal here was to send the data in real time. So as I was saying, within cards, there is a limit between 1 to 5 seconds before we can personalize the behavior of the next card. So that was our sort of barrier to get the data into these systems. And then all of our traffic is primarily based on push notification. So whenever we have push notification, that's our traffic spike period. So we wanted to make sure that when one of those push notification goes, our entire system scales automatically. It means we have 1 user to 1 million users coming in. All of our partners should be able to get the data at the same cadence rather than slow down when we have heavy traffic. And then every partner has a different ingestion type. Some had an API, some give us direct access to their store so we can update the data there. So we wanted to make sure that this delivery system is flexible enough so we can integrate with any partner rather than just a specific partner, a specific way to do it. And then almost every partner has a way to throttle the service. They have a limit bandwidth that we can hit them. So we wanted to make sure that this delivery system was able to customize to the partner's bandwidth and throttling mechanism. And then oftentimes when one of the partners' API is down, we wanted to make sure that doesn't affect other partners. So it has to be very into its own kind of container mechanism so that it doesn't affect them. And the last and the important one was, once the data is in the segment, we wanted to make sure that our internal users of that data doesn't get affected by these access and seeks of the data when we send to the partner. So that involved making sure what data changed and seeks and scans. We didn't make sure that our store performance was not getting neglected during this transfer time. So my friend Sid is going to talk about the actual architecture for the platform.
Good afternoon. I'm going to discuss to you the architecture that we use in order to achieve this particular task. So there are 2 important features that I wanted to emphasize in this architecture. One is the real-time customer segmentation. Part of it is already discussed by Sudhir, and the other one is the real-time customer activation. So if you look at this box over here, the classifier box, that is basically our real-time segmentation. What is important here is we combine 3 different sets of data. One data is coming from the actual gaming platform. So we have a profile table of users in this platform. And what we do is we hook, in its trigger, we hook a Lambda that would update our cache. So we need to be in a Redis cache in order to be very fast in the way we classify the different segments for a particular user. So this Redis cache is instantaneously updated every time there is a new user that is created on the game platform or a returning user that is updated in the profile. So the other set of data is the segmentation rules. So we crafted a segmentation rule in such a way that we would be able to instantaneously classify a particular incoming user in order to exclude or include that particular user in a set of segments, or shall we say set of attributes that a particular business shall we say campaign or business offering is trying to target. So we expose a web UI so that this tool will be utilized by our salespeople so that they could create the different segments they want or audience that they want. And this is translated into our meta store. And the last data unit that we want is the incoming event. So the incoming event is also already part of our platform, like an event tracker platform, so that all mobile apps, all different apps that we have in the wild would always ping us and send us the different events that are going on. So we are listening to particular events that we want to trigger this classification per user. So what is important here is the timing. When I say timing, because this is a real-time classification, we want to make sure that a player that launches the app, by the time he engages to the different features or opportunities available in the app, we already have the updated tags of the profile so that we could already react to those particular profile tags in terms of the offerings that we want to offer or the personalization that we want to show that particular user or the different ads that we want to show to that particular user. So we have an SLA of about, a window of about 5 seconds. So it's really long, but then it could be shorter in different scenarios. But what happened here is if a new user comes in, it updates or it creates a new profile in the game engine or game platform. It immediately syncs up with our cache. And then at the same time, it triggers an event, which we also track. And that event is forwarded to our classifier. So let's say, for example, this event is the one that tells us that that the user is ready. The user already launched the application, and the user is ready to about to engage in the application. So this event is captured or tracked in our system, and it serves as our trigger to classify a particular user. So we have about 1,000 milliseconds to classify each user. So that's good enough time to create what we call a CDP profile. A CDP profile is nothing but a key value pair. It maintains the same user identity of that user because we are going to use it across the different features of the applications, both on the CDP platform as well as the game platform. And then we have the values or set of strings that are actually rules or classification rules, whether it's a inclusive or exclusive rule. So let's say, for example, we have this user belongs to group ABC, does not belong to XYZ, etc., etc. So with all this in about 1,000 milliseconds, we were able to create this profile, CDP profile. And then we persist this in DynamoDB. So let's now go to the second feature, which is the activation part. So we researched different AWS services, and we found out that the best way to instantaneously share and activate this particular CDP profile is through DynamoDB in combination with DynamoDB streams in combination with Lambda process. So all these three would now give us instantaneously the different sharing capability that we need in order to reach our activation partners. At the same time, we cross-connect to our different regions. In this case, let's say region 1 to region 2. And also, we also use the Lambda to persist all the different tagged profile to our data lake. So this data lake here has a different purpose, like not necessarily the purpose of an activation partner, but in terms of activation partners, we have plenty. So the good thing here is that you can throttle, you can activate, deactivate, and it doesn't lose the power or the performance of this platform. And so with this combination, DynamoDB, DynamoDB Stream, and Lambda, we were very satisfied with what we want to achieve. You want to add something else?
It took us a lot of fine-tuning to kind of measure. So in terms of the actual times, by the time a profile change is made to the time the data goes to the partner, we measured the latency between the actual write and the time the data goes to Lambda, and for a cold Lambda it was around 1 second, for a warmed up Lambda it was around 500 milliseconds, meaning the data is written to the process time was 500 milliseconds. And it took us a lot of time to fine tune this in terms of finding the right IOPS of the DynamoDB, the right partitions, the right sharding size. There is a limitation on Lambda and DynamoDB that streams that you can only have 2 concurrent readers. Anything more than 2, it's throttled. We are using close to 4 now, and we are starting to see some throttling happening on the streams. So probably adding another sort of queue service in the middle will help us to alleviate that and be able to add more partners into the service. So, go to the next slide. To the next slide. So quickly, some of the benefits that we had with AWS. Initially, as I was saying, we were looking for a segment store. We knew we wanted a NoSQL because it was a perfect key value store use case. But the combination of DynamoDB and streams was a perfect combination. Otherwise, we'd had to implement our own NoSQL solution, and then we had to make sure that the changes to the store are being copied in a stream, so it's processed. It would have been a much bigger project had we not had this combination of the store and the stream itself. And the Lambda integration works seamlessly fine. There is no charge for the reads from Lambda on the stream, so that allows us to kind of scale without having to think about how many times I have to read the same stream again and again. Lambda really scales well. I think it's sort of a known fact by now, but in our tests, they really performed well. None of the partners were able to see any latency in our peak times per period too. So, and obviously we didn't have to over-provision our services to cater to the high peak times and low peak times. Lambda does it on its own. And all of our services were executing within the Lambda service stipulation time, so we never had that issue of processing too much time into the Lambda. And then the last one is sort of a known thing. Having these managed services really helped us to focus on the core problem rather than working on the infrastructure. So, anything you want to add? Yeah, I think that was the last slide. So thanks for stopping by.